Hi guys. So in the last video, we completed a basic blockchain function, and so now we'll be hashing the data. We'll be making the proof of work algorithm, and we'll be creating a Genesis block for our Bitcoin, and that will initialize the Bitcoin. All right. So first of all, hashing. What hashing is, as I explained in the previous video as well, that hashing returns. So basically, we'll be using SHA-256. So what it does is it takes a string input and it returns a string with random values of characters and numbers. All right. So suppose if I write Kush, so it will give me this output. But if I do Kush 1, and this will be out of date. So you can see that the hash changed drastically. So we can never get the value of this string from this hash, but always this string will have the same hash. So suppose I go back to Kush, I'll have the same hash every time. So that is a method that we use to verify. I'll explain it more in depth later on in this video. So So let's go to our blockchain.js file, and first of all we need to install uh, a package, npm package, that will help us in creating our what do we say, our hash SJ256. So this will create a node modules folder and it will add SJ256 in it. And on the top of our blockchain.js, we'll import this file. Now this is not ES6, so we'll import it like this. SFJ256 is equal to required, and we'll add SFJ256 in here. I hope this you guys understand this. So let's just try and use this SHA-256 function first. So what I'll do is, okay, so let's create another prototype function that will hash the given data. So it will be called blockchain.prototype dot hash block, and this will be a function that will take in several parameters. The first parameter that will take in is previous block hash. It will take in a current block data, and the next thing that it will take is is a nonce. So I told you that I'll explain what a nonce is. So here is the part where the nonce comes into the play. So first of all, we'll create a data string, a total. We'll combine all these data and create a string of it. So that will be previous block hash plus current block data. But our current block data is not a string, it's a JSON object. So we'll do JSON dot stringify, and we'll pass current block data in it. And to that we'll add nonce dot to string function. So nonce was a number, numeric value. Now this will convert it into a string. This will convert it into a string. So we'll get a total string data, and to create a hash of this data, we'll just do this and SHA-256, and we'll pass in data as a string. So this will return us a 256-bit hash of our data as a string, and we'll just return this hash. So this was our hash block function. Let's just test it. So for testing, let's remove all this lines, and let's start with Bitcoin dot hash. Now in the hash block we had to pass in several parameters. So the first parameter was the previous block hash. Let's just assume it to be alright. Then we had a current block data that will be equal to, that will be a JSON object that will have so this will be the array which will have objects. So the first is amount 10, sender I can't type. Sender is an address and recipient indicate an address, and I'll just save this. So this is the current block data and we'll hash it here. We'll pass the previous block hash and we'll pass our current block data and we'll pass on the nonce. So I just give it a random nonce for now. So, and I'll tell you how we get this nonce data, but I'll just what's that nonce 200 let's say, and I'll just pass the nonce. And let's just console.log this whole and let's comment this out. And now if I run this, okay, nonce.toString is not a function. Right, let's see. Yep. Sorry, this was a capital S. As you can see, it returned us a hash based on the data, that is the current block data, based on a nonce, and based on the previous block hash. So using these three parameters, it created a string, data as a string, and it created a hash of that string. Now, how is it useful to us, right? So whenever you, the biggest feature of a blockchain is that everything that is added to the chain is first verified. So we mathematically verify all these. All right. So how do we mathematically verify? We have a proof of work method. So what a proof of work is? So as you can see, our blockchain is just a list of blocks. All right. But we always want things that to be added that are correct, which has the correct transactions, the correct blocks. And so if not, if we don't have the correct transactions or correct data, then people can fake how much Bitcoin they sent to someone else or how much Bitcoin they received from someone else. And so we make the data legitimate by proof of work. So a proof of work method is basically, it will try to generate a specific hash. All right, and from this specific hash, for us, this specific hash will be a hash that starts with 4 zeros. So for example, we had this hash with us. Alright, now we want, so this was the hash that was created by this hash block function. What we want is, we want to create a hash that will have 4 zeros in its start. Alright, so our proof of work function will do exactly that. So it will keep on repeating this hash block function with different iterations of nonce. So basically it will brute force the nonce value to generate a hash that has 4 zeros in its start. Alright, that is how proof of work will work. So how can we do this? It's simple. In proof of work, we'll start with the nonce value of 1 and we'll keep on increasing it, and we'll keep on running this function. As soon as we get a hash which has the 4 zeros in its start, we'll stop the function and we'll return that hash. Alright, So let's start it by doing this blockchain dot prototype dot proof of. So again, if you have problems understanding why we are using proof of work and why is it proof of work is being done, so this is a coding video. This is not an explanatory video of all this in details, but I'll add resources down here which will help you understand how proof of work actually works and why is it needed. So this is a video. We have various videos on YouTube which will explain proof of work, proof of stake, and various other verification techniques. So I highly recommend you guys to watch this video on how does blockchain actually work by 3 Blue 1 Brown. It's a 26-minute video, and it actually explains the whole process that we are actually coding right now. Alright, so the process that we are coding is explained in this video quite well. So I recommend all of you to just check this out so that before watching the video, so that you guys can totally understand what I'm saying and have no, I hope you won't have any further queries. So in proof of work function, we'll have various parameters, like we'll have a previous block data. So I'll have previous block hash and I'll have a current block data, and I'll just these two, and I'll be calculating the nonce. So the difference that you see in the hash block and proof of work is that we give it a nonce, and in proof of work we calculate the nonce. Alright, so let's just call it let nonce is equal to 0, and let us create a hash with this nonce. So I'll just call this function of hash this dot hash block, hash block. I'll pass it previous block hash, and I'll pass it current block data, and I'll pass it the nonce. And this will return us a nonce with 0. Alright, now what do we want is that while. So now we want to brute force this again and again until we get a hash with 4 zeros in the start. So how will we do that? While hash dot substring 0, 4. So as you can see here, substring is 0 base index number of substring. So it returns the substring at specified location. So what it will do is it will return the first 4 characters of the string, and we'll compare it with what we want. So we want is 0, 0, 0, 0. So if we get this, what we need to do is we need to increase the nonce plus plus. So this loop will run until the hash substring is not equal to 4 zeros in the start. So what this means is this loop will run until we get a hash which has, until this hash value is something which has 4 zeros in its starts. So I'll create a hash that is equal to this dot hash block, and I'll have a previous block hash, and I'll have a current block data, and I'll have a nonce. So as you can see in this loop, we are continuously increasing the nonce and we're passing on the hash, and as soon as we are done with it, we will return the nonce. So this is our proof of work method. I hope it's simple to understand because it's actually quite simple. Blockchain is not that tough to say to code, but it is tough to understand. So once you have your understanding clear, all this will make sense to you a lot. Alright, so now we created this. Let's go to our test.js file, and let's just do, instead of hash block, I'll call proof of work with the same parameters, and I don't need to pass a nonce to it. It will return me a nonce. And I'll just run this. As you can see, it returned me a nonce of 10075. What does this mean? That in 10,075 iterations, it got a block that had 4 zeros inside. To explain it more, I'll just I'll console log all the hashes that we are getting. So instead, I'll just console.log hash. So you can see the whole process in action. I'll just increase this terminal size. I'll clear it. Just run it. So as you can see, it is brute forcing all the nonce values, and the last all the hash nonce values to generate hashes. And this is the last hash that we got, which had 4 zeros in its start, and so it stopped the loop and it returned us this 10075. I hope this makes sense to all of you. If you have any questions, please put it down in the comments. I'll try to answer it as soon as possible. Alright, so we got a nonce value of 10,075. So this is the nonce value that we'll be actually using it. So let's just see whether this nonce value actually is correct or not. So now as we got the nonce value to be 10,075, let's just do this thing. Let's create this. Alright. And let's just check whether this nonce is correct or not. So how will you check it? Let's console.log this dot, sorry, not this, bitcoin dot hash block. I'll again hash it with the same nonce, and let's see if it returns us a hash with 4 zeros. So I'll pass in previous block hash current block data and the nonce. And as soon as I do it, let's just run it. Okay. I'll just, so I'll remove this console log for now. And let's run it again. So as you can see, I'll do it again so that it's clear. As you can see, it returns us the same hash that we saw in that console log. So indeed, our nonce is correct, and this is a way of verifying. So suppose you have a transaction, you have a nonce value, and you have a difficulty value. What is a difficulty value? So a difficulty value is the number of zeros that we are providing. We can increase that number to 6, we can increase that number to 5, and it will take incrementally more time. So that is why we have it. That is why the Bitcoin is so secure, because it has a difficulty in 30. In the range of 30s. So what happens is, as soon as you start computing start this proof of work algorithm and compute the nonce, it takes a lot of computing power to generate that nonce. And once it has been generated, it cannot be altered. And so that in that way, it is a very secure transaction or secure block. So if someone has to change the block data, suppose I hack into Bitcoin and I change the recipient to my name. So suppose this is my address and I change the recipient to this in the current block data. Now I'll have to redo this proof of work algorithm with this current block data as so I'll show you. So suppose we change this and I hash this last current block data. I'll put the nonce to be 10,075, I suppose it was. I'll put this nonce, and if I see now, the hash that I get is not starting with 4 zeros, and this way anyone can verify that with the given nonce and the given data, your difficulty is not matching. So we should have 4 zeros in the starting with the data. So if I so to get that, what I need to do is I'll need to again recalculate the nonce with the given new data, and if I do that, after I'm done, I'll get a hash with 4 zeros in the starting. So if I have to change some data in a block, I'll have to go through this whole process of changing this data. And also you can see that while hashing, we also pass a previous block hash. So you can see that when we hash it, we generate a data, and now we can use it in the next block as the previous block hash. So suppose this was block number 1, and in block number 2, I pass on this hash as the previous block hash. Now suppose I change the data out here and I also change the nonce out here, but this previous block hash would also get altered. So in the next block, that will be the block of index number 2. Index number 2 block will also have a changed previous block hash in it, right? It will have a changed previous block hash. So when you do again, when you hash it, you will not get a hash that has 4 zeros in its start, and so on. All the list, the whole blockchain will get changed due to just one change in this recipient of the first block item, and that is how it gets secured. So I'll just maybe have something. Yeah, blockchain demo. So if you go here, you'll see this hash, and this is a block, and this is a blockchain. Let's go to blockchain. And I have block number 1, block number 2, block number 3, and these are all green right now. So that means these are verified. So as you can see, the previous block hash is 000, this hash is this, and this has been put up here in the previous block hash, and so on and so on and so on and so on and so on. So this hash is same as this previous hash block. So suppose I change the data out here, it becomes red. So it doesn't match, this hash doesn't match with the difficulty, that is to have 4 zeros. So we have to mine it. Mining is running the proof of work algorithm. So as you can see, it changed the nonce out here to make it 4 zeros. Now we can do this in the last block, but what if we change the data of the third block? So as you can see, as we change the data of the third block, the subsequent blocks also get unverified, to speak. So we have to block this, mine this to get 40001, and then we have this previous block changed out here. So this is equal to this. So now we have to mine it again. Even if we didn't change the data, we have to mine it again because the previous block hash has changed. So we mine it again, and we have to mine this again. So for a hacker to change the data of any block in a blockchain, he will have to also mine the next subsequent blocks, and mining takes a lot of time. So there are mining pools in China and many such places which have hundreds of GPUs working to mine one block of Bitcoin. So that is how it is so secured. All right. So next thing, after we have done this proof of work, the next thing, so this was basically almost everything that you have to cover up in a basic Bitcoin clone. I mean, there is a lot of more complications out there, but we'll stop at this. So the most important thing that we forgot to do was creating a Genesis block. So what that means is, a Genesis block is the block that will always be in the index 1 of your Bitcoin. So you can also find out the Genesis block of Bitcoin. You can just search it. Sorry, Bitcoin Genesis block, and so Genesis block. The first block in the Bitcoin blockchain was the Genesis block. If you go to this, this is the Genesis block. So no, this is Blockchain Explorer. So in the Blockchain Explorer, you can find out the Genesis block in the Blockchain Explorer as well. I'll not go deep into it, but every like Ethereum or Bitcoin or any such blockchain always has a Genesis block in it. Alright, so the Genesis block came on 3rd January 2009 when Satoshi Nakamoto mined the Bitcoin. It had a reward of 50 Bitcoins. So what happens is, how do we earn Bitcoins? So to earn Bitcoins, we have to mine this. So this process of doing proof of work is called mining. So there are people all around the world that do this process to mine a new block and to add it into the blockchain network. All right. So, and they get some reward. So now this reward changes every, I guess, 4 years or so, and the difficulty also increases. So right now, I guess the reward is 12.5 bitcoins per block mined, and in 2020 it is going to decrease. So let's create a Genesis block. So to create a Genesis block, we'll just have a constructor function called in the blockchain function itself. So what we'll do is this dot. I'll add a create new block function out here in which I'll put in 100, and this would be 0, and this would be 0. So the nonce was 100, the previous block hash was 0, and the hash of this block is 0. So this is how we create a Genesis block. Now if you just remove all this and just do, and we have this blockchain, let's just console.log our Bitcoin. And as soon as we do this, we clear this up. So as you can see, the first block that has been added in this is a nonce 100 and hash 0. So this is the Genesis block. And afterwards, after this Genesis block, you can keep on adding more blocks. So Bitcoin dot create new block, and we can add the random nonce, and we can add a random address, and random this. But so one thing that you can do is you can create previous block hash to be, you can use this, and you can get the previous block hash to be this dot get, sorry, Bitcoin dot get last block, and we'll get last block and dot this dot get last block. It will return as a block dot hash. And just console log this. So as you can see, it returns as 0. That was the previous block hash. We'll use that to create a new block, and then again we'll console.log Bitcoin, and we'll save it. Now as you can see, we have two blocks added in the chain. The first one has index 1 with hash 0 and previous block hash to be 0. Here we have this hash and previous block hash to be 0. And let's just do it once more to get an idea of it. I'll remove this console log and save this, and I'll change this to be something else. And, sorry. Now, as you can see, this hash and this previous block hash match, and so we have started a process of linking the chain. This is the first block with nonce 100, and this is the second with nonce this, and this is the third with nonce this, and so on. Now to calculate the nonce that we are passing out here, we'll use current block data, and current block data can be the first block, the previous, this can be equal to previous the Bitcoin dot pending transactions, so as you are passing out the current block data, so right now we are passing this as the current block data. We can change this to be transactions, and it can be equal to Bitcoin dot pending transactions, and you can use this data to create a new nonce for your for your block, and you can pass in this previous block hash, and uh, with that you can generate your new nonce from proof of work. And using that proof of work, so first you will here do proof of work, and after that you will do create the hash of that, and using that hash you will pass it out here, and this will create a new block with the given hash and given nonce. So that is how the whole process of a blockchain works. I hope it was clear. If you have any doubts, please feel free to comment it. Uh, I know it was a bit out of order, but I hope I made sense. And so this completes our series of coding a blockchain and creating your own Bitcoin. Now, as I mentioned, I am referring a book called Learn Blockchain Programming with JavaScript. So this is the book that I am referring to right now, and this book has this was one of the chapters in the book, this whole code. And the next, we also make an express server for our blockchain, which will be decentralized server. So if you want further series on how to generate a server for the same Bitcoin that you created, and how to actually create some endpoints like mine endpoint, and so you will be creating your own block explorer, which will have an HTML file, and you'll have a server of your own. Alright, so to create that, you'll have such routes that you will be passing on. So if you want that, please comment below if you want another series on how to create the whole explorer thing for your blockchain. And so what is a blockchain explorer? I'll just tell it fast. So in a blockchain explorer, you basically get all the blocks and all the transactions that have been added in that blockchain. So you can see transactions, the blockchain, average value, average fee, difficulty. So right now this difficulty is this, and then unconfirmed transactions. What is the value right now? So we can also generate a block explorer for our own Bitcoin like this. Alright, thank you for listening, and I'll add the resources down in the comments. Thank you.